Yes. So when we look at the schedule, you can see on here that we have the correlation and regression sections and then the exam just like normal for the next week and then the week after. When we get down to exam number 8, there's nothing after exam number 8, so that's all we're going to do that day is exam number 8. Grade checking day is an optional day for people because sometimes like they're late with their homework or something else happens, but I just want to give myself an extra day just in case something happens. So that's an optional day. You don't have to come that day. And so then August 13th is just exam number 8. We just do it. Then August 15th is grade checking day, and that's optional.
Is assignment 17 is also on Blackboard?
Yes.
So could I like upload that and email it to you, or
Sure, you could.
if I just go to the test?
Well, but it's actually due on the 8th.
Oh.
So then you can just do it and turn it in on the 8th. So yeah.
So on the 15th, do we get like points for like?
No, it's optional.
Okay, so it's legit optional.
It's
not like
legitimate optional. Yes, that's right.
Okay.
It's the right kind of optional.
Okay.
Yeah. All right. So yeah, any other questions about the schedule? All right. So yeah, if we go to oh, and there was a question. Are we going to have any two-tailed tests? The answer is no, so you don't have to worry about that. We will get some when we do correlation and regression, but they'll be pretty obvious, and they're not really that hard, so we'll get there. None of the others, I think, are two-tailed. So what else? Anything else? Nothing. So if I go to resources, and I go to practice tests, and I'm looking at test number 6, then the instructions here say, I can ask you any of these questions. I could ask you to state the hypotheses, find the test value, find the critical value, make a decision, or do the summary. So I am not going to have you take a problem and go all the way from beginning to end. I'm going to give you the situation and then ask you to do one of those 5 things, okay? And when we talk about the p-value test, we're only going to use that for proportions because when you look at the table for the other things, you could only find it between values, okay? So you can't specifically do the p-value. Well, I'll show you how that works in just a minute. But so p-value questions will only be asked regarding proportions. And so you will need table, I will print for you table E as well as tables F and G so that you can do all those things. All right, so for number 8, I actually do the test value calculation for you, but I require you to do the rest of the problem. So, you know, I might, for number 8 on the real test, I could perhaps ask you to find the test value, and I'd tell you the critical value, and then make you go through the rest of the test. When we do the summary of the conclusion, there is one question on here where I say to write the full conclusion. And when you're looking at this thing here, the parts of the conclusion, the only thing that really we have not done yet is that we have specifically not said you should put your confidence amount at the beginning of your statement. So that when you get to the end of the problem, you would say, with 95% confidence, there is evidence to prove this, or there is not enough evidence to prove this.
Can I pull that down just so I can see it better?
Yes.
So
I will let you.
with your example on the board, how we found a p-value of 0.04, and how she covered it, but with the p-value
Right.
was, then we would include that in our final of that one?
I'm not going to require you to do that, okay? You could, it would make sense to do that, yes. But I'm going to only give it to you in situations where I tell you what alpha is, and you're using the critical value, okay? So what we're looking at here is that when you get to the end of the problem, and you're going to say, there is evidence to prove, and then you restate, like we've done already, you restate the alternative hypothesis. Then you would say the population proportion of Western students that watch Netflix is more than the population proportion of the students that watch Netflix at UWL. Okay? So we've already done this, but you have to include the specific thing that you are measuring. Okay? The type of measure and the unit of measure are the characteristics. So you would say the standard deviation, or I should say the population standard deviation of the length of the nails. So you would include those things specifically in your conclusion. I want you to do that anyway, okay? But here's a list where it talks about all the things that you should have in your conclusion. So the long form of the conclusion includes all this stuff, and we'll go through a couple of examples. So, yeah, well, let's make this work. Sure. I'll just erase this up here because I'll portion like that. All this Q bar goes away. We already did that. And we're not going to do p-value method right away. So, let's do a study of how much you would pay to watch an online movie. So you're going to click on YouTube and there's going to be a movie and you're going to buy it. How much money would you spend? We're going to go around the classroom and see what numbers we got. Okay, so we got a few people here. So just go around the room and see what you say about that thing. So, Emily, you got a number for me?
$1.99.
Okay, $2. 50 cents. 0.5. $2. Sam? 2. 2.
You just typed 32.
Yeah, well, 2. 2. Tia? 0. 3. 1. No,
0.
0. Gab? How much would you spend, Gabrielle, on an online movie? 3? 3? 3? 0?
Like 15.
15. There you go. 5? 5? $1.50? We'll round it up to 2. I'd say 5. Okay. So we're going to throw out the 15 because obviously that's an outlier. So average. 2.26. And standard deviation. $1.68. And our count, 17. Average online movie rental. Cost. $64 pay less than $1. Huh. So let's see if we can prove that this is more than $2. Is this, or is the average for stat students more than $2? All right, so let's see if you can do a hypothesis test for the mean in this situation.
So we're using that alpha is
Yeah, let's use 0.05 for alpha. All right, check your neighbors, see what your neighbors got going on here.
So, it'll be the same thing, it's a free to 16. When you scroll over to 0.05 one-tailed test, that would be 1.5. So that would be your critical. And because it's a right-tailed test, you don't do one, it is kind of, because on the t-distribution, if we're talking about a one-tailed test, it's already correct, shaded regions, right?
All right, Hillary, what do you got for null and alternative hypothesis? Okay. So now we're getting back into the situation where we're comparing one thing to a standard number. We're not comparing two different groups. We have a number and we're comparing to it. Okay. So Emily, what's step 2?
Finding the critical values, so you want to search.
Okay, where do you look for that? Table F. And so degrees of freedom is 16, and it's one tail, alpha 0.05, and it's to the right, so it's positive, so there's my critical value of my rejection. Okay. And this is T. When we were doing proportions, we were looking at Z. Now that we're doing the mean, we're talking about T. Casey, what's next? Okay. So, Luann, you got test value? Okay. Caitlin, you got test value? Okay. Mattia, you got test value? Oh, okay. So, Jessica, you got test value? Not what I got, but I got 0.638. Okay. So we should have 2.26 minus 2 over 1.68 divided by a square root of 17. And that would come out to be 0.638. Yeah, that's my test value. Tia, what's my next step?
And the critical value,
No, I already did that. I got critical value and test value.
make a decision.
Okay, way to make a decision. So Elena Schmidt, what do we do for that?
I said do not reject the null hypothesis.
Okay, and why not?
It's not in the rejection region, the test value is not in the rejection.
Okay, yes. Test value is not in the rejection region, so we do not reject the null hypothesis. Crystal, right? What is that?
So if we don't reject it, it means that there is not enough evidence to support that the average stat student pays more than $2.
Okay. Okay, so there's not evidence for the alternative hypothesis, which would be that the average for stat students is more than $2. So we cannot prove that it's more than $2. Even though the sample came out to be that, we cannot prove it. It could just be a random fluctuation. Okay. Now, I'm going to change this, and I'm going to ask the question, is the average for stat students less than $3? So that's going to change this to be mu is equal to 3 and mu is less than 3. That's going to change my critical value to be a left tail test now. So it's negative 1.746. And my test value now on top of this fraction will be 2.26 minus 3. But everything else comes out to be the same. And in the interest of time, I'll tell you that number is negative 1.816. What will I do now? Mara, what would I do with this? Okay, Sierra, what would I do with this now? No, I reject the null hypothesis. So I'm going to reject the null hypothesis. Alex, can you tell me what happens when I reject the null hypothesis?
Yes.
Okay. Gabrielle, can you tell me what happens when I reject the null hypothesis? I'm sorry, we what?
We made a decision.
We make a decision, yes we do. What decision do we make?
We decided that there was enough evidence to support the alternative hypothesis.
That's correct. There is evidence to support or to prove but now we're going to say this using the full form of the conclusion. Okay? So we're going to use all the parts that are in this thing, parts of a conclusion. Okay? So we're going to say I should use a different color. One, two, three, 4, 5, 6, 7. With 95% confidence. The reason why I say this is that clearly if I changed my alpha I would change my conclusion. If I have a different value of outcome, my conclusion comes out to be different. So I'm telling people that this is the amount of confidence I have. 95% confidence, which would be 1 minus alpha, okay? And it's not the same thing as a confidence interval, okay? Confidence intervals are 2 tailed. This is just 1 tail. With this amount of confidence, there is evidence, and I know there is evidence because I rejected the null hypothesis, right? That the population mean, because that's what I'm measuring, and then what am I actually measuring? I'm measuring online movie pricing. And then I say, where did I get my sample? My sample was from stat students. And what am I trying to prove is less than. And what am I comparing it to? $3. Now, this is not going to be a lot of questions on the test, but it is going to be 1 question on the test, okay? So I'm going to say to you, I want you to do the long form of the conclusion. That's what this is. So you say, with this amount of confidence, there is evidence that the population mean, it's important to have that word in there, of online movie price for this group, statistics students, is less than, comes from the alternative. Now this $3, I just pulled it out of the sky, so that's just the $3. If it had been some national number, I would put the national number on there. But it's not, it's just a number.
You want us to write this in paragraph form or with the numbers?
Paragraph form is fine. If you put the numbers, that's okay too. So hopefully you understand how these possible statements would change. If alpha were different, I'd have a different amount of confidence. If I say do not reject, then I say there's not evidence. If I'm talking about the standard deviation, then I would put population standard deviation, not mean. And then what is it I'm measuring? Is it the length of the nails? It is the sodium level, or what is it that was in there? And then who am I asking? All right. That's the population of interest here that I took my sample from. Again, it's the population mean of statistics students. It's not the sample of statistics students. I'm assuming that you people are representing all the statistics students. And then the direction comes from the alternative, and then the number also comes from the alternative. All right, so that's that. That's the long answer. Now I'm just going to mention for you what role the p-value would have in the situation, because this might show up, all right? When, not on the test, but later on. When we look at the t-table, right? I said it was negative 1.746. That was my critical value. And that corresponded with an alpha, a one-tailed alpha of 0.05. Could I take this further? Could I go out here 0.025? The answer is no, because that would be 2.12. So where is my test value? My test value is between here and here. So what is my p-value? My p-value is between here and here. So I could say in this situation that my p-value is greater than 0.025 and less than 0.0. By using the chart, I can't tell exactly where my p-value is. But I know as I go further down the chart, alpha gets smaller. So that tells me my p-value is somewhere between 0.025 and 0.05. But if I have a computer, it will actually tell me what the p-value is. If I use the t-distribution, and it comes out to be 0.044. So when people actually do research, they don't use tables. They just put numbers into the computer, they find the p-value, and they tell people what the p-value is. Emily?
I just want to make sure that I understand. So for like looking at the table, if you do the 0.05 above it, it says the confidence interval is 90, like you said, 95%.
We are not doing confidence interval, we're doing hypothesis testing, which is one tail.
Okay.
So we're not going to use that number from the top of the chart. We're going to use the one tail number.
Okay, so basically it's because 1 minus 0.05 would be 0.957 or whatever. I'm just trying to figure out how to understand this.
Yeah, my basic statement to you is don't look at that number on the top.
Yeah.
Because the number on top is confidence interval.
Yes.
And that's two-tailed.
Yep.
Don't look at the two-tailed part, because this is also not two-tailed. Just look at the one-tailed part.
Yes, but how my brain's not.
Oh, well then, we'll let your
95%
brain take a vacation here and go. Okay. So now the only other thing we have to do is the standard deviation.
Just the other question. He's
Oh.
just wondering why you said 95%. That's because it's 1 minus.
Oh, this 95%?
Yes. That's what I was trying to figure out.
Because I said 5 and it's one thing.
Okay.
Right here. There. Thank you. All right. So now we're going to ask the question, is the standard deviation of online movie pricing or Stat Jul more than 1.3? So I think some of you might benefit from conversation with your neighbor about how to do these kinds of problems. So I'll give you that opportunity right now. Others of you might be hard pressed to find a neighbor that's actually got something to show you.
So do you have the alternative policies? Right. So if you primarily
Is 1.746.
right, that's what I got.
Okay.
And then the test value is, the equation, it's the equation. Okay, the equation is, n minus one, this is a fraction, so n minus one in parentheses, and then times s squared over the standard deviation squared.
Okay.
So that should give you the test value. Right, it's not allowed. You have 16. Oh, times, not minus.
All right, Casey, you got null and alternative hypothesis for me?
Or the thing.
Okay, now we're gonna find out what that thing is right now. We're gonna use that word here. No, sigma.
Yeah.
Sigma is equal to 1.3, and the alternative?
Is sigma is greater than 1.3.
Okay. So then we need critical value. Emily, where are we gonna look for critical value?
Table G.
Table G. And what do we find when we look there?
So degree of freedom would be 16, 4.05 would be 26.296.
It is 26.296. And what distribution are we talking about? Emily?
Chi-squared.
Chi-squared.
Is that what you mean?
That's what I mean. Chi-squared. So it's 0 over here, and 26.296 there. Degrees of freedom, which is 16, that would be in the middle here. But there are no negative numbers on the chi-squared. Okay. Crystal Wright, what am I gonna do next?
I don't know, I still don't understand how we got 26.296.
Okay, we're looking at table G.
Okay.
So yeah, you won't be able to find it if you're not looking at table G. Because this is the chi-squared. Because we're doing standard
Oh, so it's
deviation.
not table F, that's the problem, okay.
Yes. All right. So far, so good. Lena Schmidt, what do we do next?
On the test value.
Find the test value. And the formula for test value?
N minus one times s squared over the standard deviation squared.
Technically, we should not use the word standard deviation because S is also a standard deviation. So we should say sigma squared. We have the sample standard deviation and we have the population standard deviation, both here. And so this would be 16. And Elena, what numbers go in here?
I got times 1.68 squared.
And then on the bottom is the 1.3 squared. So that gives us a number. What'd you get?
26.2, or I'm sorry, 721.
26.721. All right. Tia, what happens next?
Make the decision.
Okay, and what do we decide?
That you would not reject it,
How would you know?
because after that number.
If it's after that number, then it is in the rejection region. So we do reject the null hypothesis. So we reject the null hypothesis. Mara, can you tell me what that means? Okay. Gabrielle, can you tell me what that means? Okay. Sierra, can you tell me what that means when I reject the null hypothesis?
When we do the long, do you want the long?
No, I just want the short one.
There is sufficient evidence.
There is evidence. Of what? The alternative hypothesis. When we prove things, we say there is evidence of the alternative hypothesis. All right, so that's enough, I think, for today. I'll plan to see you on Thursday for the test. Well, the other stuff first.